Anyway, all right, so let's go ahead. Which parent is this example number 3? Which parent is this? And we only have 2 new parents in this section. Yeah, so it's that reciprocal square parent. And remember, this is the one that has the identical, well, not identical, but those curves that are both in the top half of the graph, okay? Not the ones that are in the opposite quadrants, but they're both in the top half of the graph. Okay, so let's just take a look. What would be a description for the way that we're gonna mess with our parent? How are we messing with our parent? Okay, so we're gonna go to the right 4 and up 2. Now, if you remember from a week and a half ago, the easiest thing to do is to move the asymptotes. Don't worry about all the special points, just worry about moving the asymptotes. Once you have the asymptotes placed, that's kind of like your new origin, your new X and Y axis, and you can just go from there. It's a little easier, in my opinion, to do that. We'll worry about domain and range after we have a graph. So when you think about moving your asymptotes, if I take, remember I had 2 asymptotes. I have a horizontal asymptote on the x-axis, and I have a vertical one on the y-axis. So when you take your horizontal asymptote and you move it right and left, it doesn't look any different, okay? But if you take your horizontal asymptote and you move it up 2 units, now it looks different. So let's take our horizontal asymptote, move it up 2. And remember that the vertical asymptote was on the y-axis. That's where it started out. So if it's on the y-axis, again, if I move up and down, that doesn't matter. It doesn't make it look any different. But if I move it right or left, that's when it's going to make it look different. So we're going to take our vertical asymptote and we're going to move it to the right. We're going to go 4 units to the right. And where our 2 asymptotes cross each other, that's kind of like your new origin, your new 0, 0 point. So just think about that, and then we can put our curves in the way that we want them. So think about your special points. On the reciprocal square parents, when we drew the parent on the video, how did we get to the special points? Right 1, up 1, and we also went, somebody else? Left 1, up 1. So that's exactly what we're going to do, only instead of from the old origin, we're going to do that from the new origin. So we're going to go right 1, up 1 and get a coordinate. Left 1, up 1, get a coordinate. Draw your curves, and you're done. And then once you have a graph, domain and range is pretty simple after that. So what's the domain as you look at your graph? Good. What kind of a bracket, square or round bracket on the 4 rounds? Why? Yeah, you can't touch the vertical asymptote. All right, and then we've got union with, somebody else finish that. Yeah, 4 to positive infinity. So basically it's all real numbers, just skip over the number 4 itself, okay? All right, let's get a third person. How about the range? From the bottom, what's the bottommost value that we're using? Yeah, 2, and technically we're not even using the 2, we're using everything right after the 2. All right, so we have a round parentheses on the 2, and then we're gonna go all the way to infinity. Okay, so that finishes up 5-1, and it also kind of gives us a review as to what we did a whole entire week and a half ago. Okay, any questions on those 2 parents? Okay, now if you remember, do I have this as a title? Yeah, rational functions. The word rational simply means fraction. Okay, that's all this means, is that this whole entire chapter, you know, like all whopping 3 sections of it, this whole entire chapter, what we're really just dealing with is fraction equations. That's what we're dealing with. So let's take this up a notch. So the first section only deals with parents and how to mess with the parents. The second section and the third section is going to deal with, okay, what happens when you don't have a parent? What happens when it's kind of weird? And so you have to have some other ideas on how to deal with the non-parents. So let's go into 5.2. So this came from the video. You're going to have to help me out as far as, hold on, I just thought of something that I forgot to do. If I don't write it down, I'm going to forget about it. Did you guys have an embedded question in this section, in this video? No?
It just said that you won't have an embedded question for this video, but be sure to show your instructor.
Oh! Okay, well. Sorry, hang on just a second. Something that I forgot to do, and I'm like, no! Okay, so yeah, I might take a look at your notes here in just a little bit. But basically, you want to have these notes handy until you know them, until you understand them, and you got to know them and you got to understand them by the time you get to the next test next week. This is a shortcut version for the 5 things that we're going to be finding. Again, that's I believe that was on the video. If it's written on this, it was in the video. So let's just jump right on into a picture. Okay. So if we're just looking at a picture here, and by the way, example 1 is something I could have even put into section 5.1. It's not apparent, but it's easy enough information that it's not really, we're not up to the next level yet. So for 5.1, or sorry, for this example 1, what's the vertical asymptote or totes? So you're only going to get half credit for that. Yeah, why does it have to be x equals? But why does it have to be an equation? Yeah, so what kind of figure is it when you draw it? It's a line, and so we have to put down that it is a line equation. Okay, like if we have to draw a point, what kind of answer do we give? Yeah, the coordinate, right? An x and a y value. So, and if we have to give a line, we don't just give a number, we give a line equation. So since this is a line, then we'll have a line equation. So we have x equals -4 and x equals +4. Okay. What about the horizontal asymptotes? Somebody not Sierra, because she got the vertical asymptotes. Y equals 2. Okay, and then my domain. Round or square? Here's what I want to point out with this. Where are my breaks occurring? Which asymptotes? My vertical asymptotes. Okay. So here's what you need to understand. When it comes to the domain for these guys, it's always going to be from negative infinity to positive infinity with breaks at the vertical asymptotes. Always. You're always going to start with a negative infinity. You're always going to end with a positive infinity for domain. Now that's not true for range. Can you go back? Can you just pull your paper back real quick to the last question we did in 5.1? Did our range start at negative infinity and go all the way to positive infinity? No, it didn't. So that's not a true statement for range. I can only make this statement for domain. Okay? But for domain, I'm always going to begin at negative infinity. I'm always going to end at positive infinity. And my breaks are always going to occur at the vertical asymptotes. Okay, always, always, always. Okay, so find everything and sketch a graph. Okay, so here's where you're gonna need the first page from the video. Now, if it's been 2 weeks since you watched this video, you're gonna be pretty clueless right now. You're gonna have to depend heavily on your page of notes. If you watched it this morning, you might be a little bit more okay, all right? So the first thing that I'm being asked is, where's the vertical asymptote? So go to the first page of notes and tell me, where do I find vertical asymptotes according to the video? More specifically, it's what makes 0 on the bottom. I do find it on the bottom, but more specifically, it's whatever makes a 0 on the bottom. Okay, so look at the bottom. What number makes 0 on the bottom? A positive 1. But remember, when I draw a vertical asymptote, what am I drawing? A line, a vertical line. So I can't just say, oh, it makes a 0 at 1. How do I have to write that? At x equals 1. Okay, let's go put that on the graph. Because it says find everything and sketch a graph. Okay, so x equals 1, so here's 1. A vertical asymptote there. X equals 1. Okay, now go back to your first page of notes again. Okay, so Mary Alice and Sarah, you guys answered the vertical asymptote from the first page, so you guys are out. So that leaves 3 of you. Okay, how is it that you look for horizontal asymptotes? Yeah, you got to pay attention to the degrees on the top and the bottom. Okay, so Devin, what is the degree on top and what is the degree on bottom? They're both 1. Okay, so on your first page of notes, we talked about degrees that are equal on top and bottom, or the other 2 options, either the degree on top is higher or the degree on bottom is higher. Okay, so those were our 3 options here. So then, what do we do, Abigail, when the degrees are the same on top and bottom? Fantastic. What's the leading coefficient on top and on bottom? Okay, so I've got 2 over 1. But remember, when I draw a horizontal asymptote, what am I drawing? A horizontal line. So she said that my numbers are 2 over 1. How am I going to write that correctly for the horizontal asymptote? Okay, and then since it's a line, I have to write a line equation. There you go. Y equals 2. Let's go ahead and draw that on our graph. Now remember, this isn't necessarily one of our parents. For sure, it doesn't look like the parent equations. So that's why I'm treating this differently, because it's not, I can't just give it a description, okay? All right, so hole in the graph. Go back to your first page notes. What is it that I'm looking for to have a hole in the graph? 0 on top and on bottom. You might want to add this to your notes. Okay, here's an English version of that. Essentially what you're looking for is identical factors on top and bottom. Identical factors on top and bottom. For instance, don't write this down because I'm going to have to erase it. If I were to rewrite my equation a little bit, come on, be nice to me. Do I now have identical factors on top and bottom? Yeah, I do. And so if I have identical factors on top and bottom, I would have a hole in the graph, bless you. Okay, so it is allergy season, is it not? Yes. Okay, so this is the first year in years and years and years. And like when I was a kid, did you guys ever get allergy shots? I got allergy shots from the time I was in like 7th grade all the way through college, and the only reason I stopped after college was because then I was on my own insurance and I couldn't afford it anymore. So years and years, and so I haven't had any problems after that. All of a sudden this year, it's just crazy. It's 2020, it has to be 20, it has to have something to do with COVID, right? And so for probably 6 weeks now, I've had to take allergy medicine every day, and heaven forbid if I actually skip a day. Anyway, you guys want to know that. Okay, so back to, but you took a rabbit trail, and so now you're ready to get back into math. Those of you who I was kind of starting to lose, now we're ready to get back, right? Okay, so do I have a hole in the graph? No, because I don't have any identical factors on top and bottom. So there's no holes in the graph. Okay. X-intercepts. Go back to your first page of notes. Okay. What's the easiest way to find X-intercepts? Yeah, figure out what makes the top equal to 0. Okay. You know, back when we were in chapter 4 and chapter 3, not chapter 2, we said, how did we get an X-intercept? Well, we just set the whole thing equal to 0. Okay. Well, basically that's what we're doing now. But remember, the bottom can't be 0 or it's undefined. So that's why we're only looking at the top, because the top is allowed to equal 0. So what makes the top equal to 0? Basically, just set it into a little mini equation in your mind and solve it. What makes the top equal to 0? 1/2. Okay, but when you draw an X-intercept, what kind of figure do you draw? Okay, a point. So what should I be putting in my blank then? Yeah, it's got to be a coordinate, so 1/2, 0. And we can put that on our graph. And then last but not least, the Y-intercept. So go back to your first page of notes. How do you find them? And really, this is a review question because we found Y-intercepts all semester long in every chapter. So how do I find a Y-intercept? Yeah, let x equal 0 and just solve. And so when I look at my equation, if I take these two guys and make them both equal to 0, what's left over? Just a positive 1. But when you draw a Y-intercept, what does that look like? Good, good. It looks like a coordinate. So it's going to be, when we plugged in 0 for all the x's, we got a 1 that came out. We can put that on our graph now. Okay, now pull out your calculators. Because at this point, I have found everything that I can possibly find. There's nothing left for me to find except for the curvy pieces of the graph. Okay, so I want you to go to your y= screen. And I want you to type in the equation. Go to your y= screen, type in the equation. And you can go ahead and graph it. Fix your window a little bit so we can see more of it. Standard window worked for me. So let's see. Let's look to let's compare these two because you guys have different graphs. And let's compare the y equals. That's a great question. Okay, so Abigail has made a mistake, but I'm really glad I was actually hoping more people would make this mistake, not because I'm mean, okay, but because I really wanted to make this a point today. So Abigail made a mistake that I'm very, very thankful. Thank you. I didn't pay her to do this, but yeah. So here's what Abigail did. So she typed in 2x minus 1 divide x minus 1. This is how she typed it in, okay? Now, some of you, your calculators, they just automatically do the fractions. And so, like, you don't even have to worry about parentheses, which I think is kind of lame, personally. But anyway, for the rest of you, you do have to worry about the parentheses. Abigail and anybody else who might possibly make this very common mistake. The problem is here's what the calculator thinks you've done, or thinks you want. It thinks you want 2x minus 1 over x minus 1. This is what your calculator thinks, because the division symbol is only between these two. Okay, so the rest of you, your brain did not grow. Abigail's brain just grew. Okay, so I'm very excited for her. Okay, so what we need to do, anytime you're entering in a fraction equation, you gotta have parentheses around the whole top, and you've gotta have parentheses around the whole bottom. You have to, so that your calculator knows what belongs in the numerator and what belongs in the denominator. Abigail, does that make sense? Okay, so so again, I didn't tell her to do that, but I'm glad she did. All right, so then let's just go ahead and fill in the pieces. Let's fill in the curvy parts. And so we know that our, by the way, were your fences drawn on the calculator? They weren't, were they? Okay. Why? Because asymptotes are not things you can see. Okay. It's just those imaginary lines that you're not allowed to touch. So that's why you have to come up with these on your own mathematically first. So let's use our fences. Hit your 2 points on the way. So there's the bottom curve. The top curve, I really don't have any points, any reference points that I can see. So honestly, I don't really even care. I just want to see the right shape curve. I'm really not looking for any specific points. I am looking for the X and the Y-intercepts, okay? But the other ones, I'm just not as interested in those, okay? All right. So on this one, give the equations of the vertical asymptote and the horizontal asymptote. That's all I'm being asked for, okay? So try not to look at the first page of notes. How much are the vertical asymptotes? Yeah, what makes the bottom 0? Okay, guys, let me tell you this. This to me is what's so exciting. Did you just break it? Yeah. Here's what this makes me so excited. Look at the bottom. What kind of an equation is just the bottom? It's a quadratic. Like, we spent an entire chapter 3 solving quadratics. So this is very exciting. I'm using what I learned in chapter 3 to be able to do what I need to do in chapter 5. What are the 4 methods of solving quadratics? Square root method, somebody else? Quadratic equation or quadratic formula, what else? Zero product property, otherwise known as factoring, and then the last one, which isn't an option here, the square root, wait, what did you say? Did you say square root method? Square root method, sorry, that's the one I can't use. What's the other one? Completing the square. Completing the square. Let's try factoring. We always want to try factoring because isn't it way easier when it looks like the last ones where it was like, oh yeah, I can tell what makes the bottom 0 because that's just a nice little linear factor. Okay, so let's see if we can get some linear factors going on here, and that'll make our lives a little easier. And by the way, you should never, even though right now what I'm mainly looking at is the denominator, you should never just totally ignore the numerator. Okay, just saying. All right, so let's see what we've got here. If we try to factor, what would be 2 good firsts? Sorry, just the first numbers. Like a 5x and a 1x. right, because that'll give me my 5x squared. And then what would be a good pair of lasts? By the way, there's only one pair available. 5 and 1. Now, let me show you something. Okay, this is a cool trick. Use it if you want. Don't use it if you don't want, but it does make life easier. Don't write this down. I'm going to have to erase it. Okay, if I put a 5 and a 1 here, do you see how the first binomial, do you see how it has a GCF? What's the GCF? 5. Look at the original trinomial. Did it have a GCF? No, it didn't. So if this guy does not have a GCF, neither of these guys is going to have a GCF. Neither one. So that tells me, I know this cannot be 5 and 1. I got to trade those. I can't have a GCF because my original quadratic had no GCF. Okay, so that's just kind of a trick. So this has to be a 1 and a 5. Now look at your outers. If you multiplied your outers, what would you get? 25. And then if you multiply your inners, what do you get? 1. I need a negative 26. So what does my 25 and my 1 need to be able to get a negative 26? Both negative, and let's just make sure that that checks out. If I multiply to get the last neg 1 times neg 5, does that give me the pos 5? It checks out okay. Okay. Now, for the moment, I'm ignoring the top, but I'm not going to ignore it permanently. Let's look at vertical asymptotes. What are vertical? How do I find them again? Vertical asymptotes are whatever makes the bottom equal to 0. This is way easier to see when I can see the denominator factored. What makes the bottom 0? X equals 1/5, X equals 5. Now I might have to adjust that depending on what I get in the numerator, because if the numerator possibly gives me a hole in the graph, there's no such thing as a hole. We're really not going to run into a hole in the graph at the same place where there's a vertical asymptote. Okay, so just understand I might have to use my eraser on it. So let's go ahead and let's factor the numerator as well, just to make sure there's no holes in the graph. So do I have a GCF in the numerator? Yeah, there's a 3. So just above, the first thing I'll do is I'll factor out the GCF. So help me out. I'll be left with an x squared minus, minus an 8, right? Okay. And so we've got our GCF of 3. We can't forget that. But now it's a lot easier to factor the binomials when that beginning number is 1. So I got an x and an x. What would you like to use for the 8? 4 and 2. Now, right now, I'm not even finished, but I can automatically tell you there's not any holes in the graph. So my vertical asymptotes were good, okay? But if one of these had been an x minus 5, then this is no longer a vertical asymptote. I would have a hole in the graph, not a vertical asymptote at x equals 5. Okay. Signs in there. I need my 4x and my 2x to be a negative 2. So my 4 needs to be, 2 needs to be positive. Make sure it works, and it does. Okay, so my vertical asymptotes look good then. How about my horizontal asymptotes? All right, my question is, first question is, what is it that I'm supposed to look at for horizontal asymptotes again? Good, the degrees on top and bottom. Would you rather see the degrees on the factor version or on the original version? Totally the original. And what do you see about the degrees on top and bottom? They're the same, okay? So where is my horizontal asymptote? Okay, half credit. Y equals, good, Y equals 3/5. Now, my directions didn't tell me that I was supposed to graph. It just told me to give the domain. So I want you to think back to something that I told you a few minutes ago. What's my domain? Okay, somebody else continue? Yeah, good job. So I'm beginning and ending at negative infinity, positive infinity, and I'm just simply taking breaks at all the vertical asymptotes. Okay, I would actually have to graph it to be able to know what my range was, but I don't need a graph to be able to get my domain. Okay. All right. Now, really, what we just did is totally this right here. Okay. Okay. Look at step number 6. What's step number 6? Plug it into the calculator. It's not step number 1. Okay. If you make it step number 1, I'm probably gonna find out. Because you don't get horizontal and vertical asymptotes, you actually can't even see the holes in the graph if there's holes in the graph. Okay, so you need to find the first 5 things, and those need to be on your picture before you type it into the calculator to get the curvy pieces. All right, so let's take a look here at example 4. Actually, how many examples do I have to do? 1, 2. Oh, I've got time. Okay, so how about 2, 4, 5? Okay, so let's break into groups. Okay, 2 or 3. There's only 5 of us in here. 5 of you. All right, groups of 2 or 3. Let's come up with everything on the graph first. This is not let's work alone and then we'll meet up at the end, okay? This is, I actually want you discussing every step. Rehearse to each other. How do I find the rest? How do I find holes in the graph? How do I do, etc. Okay? All right, go.
So we're just doing
Example 4.
to reason about, you know, have any set of so you've got, right, you're calculating only things this because this is a numerator. So you are yep. No, it can't. You can insert. Yeah, do second insert. So no, that's all right. Turn in second insert. Now put in parentheses. Next. Okay, so now you got your x plus 4, and you can do insert again if you want. I don't think the second took. So do second insert. Yeah, because see how the cursor changes from a black box to a blinking line? So now put parentheses in, 2 parentheses. Okay, and then you still need the factor of x plus 2. And another parentheses for the x plus 4. Yeah.
Because it says error. Because you got 1.
Where does it say error?
That's
at -2. See how this one's negative and this one's positive? It has to go through 0 between them.
Yeah.
Right? So, and that's where -1/2 would be. Is in between those two.
But I'm confused because we got the horizontal asymptotes from closer.
Good.
So then,
Okay, so then ask your group people about that. That's a good question. Ask them what they think about that.
what do y'all think?
You got different graphs. Okay, so let's compare the y equals to each other in your calculator. Let's see how, oh, so see, her calculator actually types in fractions. She doesn't even have to worry about the parentheses, which is so lame. All right, here's what your calculator thinks you're doing. May I? Your calculator thinks you've got this fraction and then you're multiplying out to the side by x plus 4. That's what your calculator thinks you're doing. So what you need is you have to have a parentheses around the entire top and the entire bottom. Where's the equation for this one? Oh, that's it. Okay, start again. So you got these, but you also need an extra set here. So otherwise, your calculator thinks that x plus 4 is on top. So what did you guys come up with? What do you think? We don't know. Okay, so you guys present the question to the other members in the class. I feel like I'm in politics. I got the right side and I got the left side. Go ahead.
Did y'all's X-Intercept go through the horizontal asymptotes? No. What's y'all's horizontal asymptote? Did y'all get an X-Intercept?
Oh,
No, you didn't do it.
oh, I got it. I guess let's go through. It's -1/0.
Yeah. But we have a horizontal asymptote at y equals 0.
So why is this a red flag, Devin?
Because you're not supposed to go through the asymptote.
You're not supposed to go through the asymptotes. Yeah. And this goes through an asymptote, doesn't it? All right, so let's stew on that for just a second. Let's make sure that we're all on the same page and we all got the same thing. What did you guys get for vertical asymptotes? Okay, so, and by the way, if you graph it wrong, this is a great way to check your work, because if you've already got these on paper and you graph it wrong, you're like, oh, wait a second, this doesn't look like my graph does. Okay, so this is another reason that the graph should be the very last thing that you do. All right, horizontal asymptote. Why did you guys tell me that this is going to be y equals 0? Can you explain? Good, the degree on bottom is larger. What is the degree on bottom? 2. And so since the degree on bottom is larger, we have y equals 0. So let's go ahead, which is right on the x-axis. So like, you can't even see it, it's on there. Okay, how about holes in the graph? Do I have holes in the graph? Nope, there's none of those because I don't have any identical factors. What did you tell me was the x-intercepts? Okay, and so when you go and graph this was Devon's thing, like, wait a second, I'm not supposed to be graphing on top of an asymptote. Okay, and I am going to come back to that. And then what was the y-intercept? 1/8. Okay, so, and you're like, where's 1/8? It's just make up something. It's really close to 0. Okay. And that's fine. All right, so let's talk about this. Well, no, let's get the curvy pieces. So what I want you to notice is basically I want the graph split up like the domain splits up. So let's talk about this side of the asymptote, let's talk about between the asymptotes, and let's talk about this side of the asymptote. Okay, so 3 pieces of my curve. Over here on this side of the asymptote, what does my graph look like? Can you describe it? So it's down here, okay? And what is its shape? Have you seen this shape before? It's like the parent guy, right? Okay, so, and I don't have any special points over here, so basically just use your fences and draw it, but you don't have to really worry about coordinates. Okay, so am I right so far? Because I didn't graph it on my calculator. We're good so far? Okay, now let's talk about between the asymptotes. So what does it look like between the asymptotes? Yeah, it looks like a parabola that's concave up. Now, I didn't make you find this, but could you find the minimum point? Oh yeah, you've been here before, right? Can you roughly tell me where that minimum would be? Where? 5? I'm trusting you because I don't know, I didn't graph it. Do you guys agree with her? Ish? Okay. All right, so it's up here somewhere, right? Now, oddly enough, it is a parabola-shaped figure, but it's actually not a parabola. Let me just point this out real quick. You remember how parabolas get wider and wider and wider and wider and wider and wider? This side is fenced in, okay? In a normal parabola, normal parabolas are never fenced in. Okay, so it is a parabola shape, but just understand it's not a true parabola. Okay, now let's talk about on the right side of this guy. Okay, so what does the rest of my curve look like? Let's break it up. Let's break it up. Can you tell me what happens between just this and this point? Like, let's forget about all this so far. Let's just talk about from here to here. It's increasing. So remember, I know this is a fence. I know I'm getting closer and closer and closer to this guy, okay? I know that. So I'm getting closer and closer to this guy. I'm gonna increase up to this guy, okay? So I'm gonna draw that so far. Now, let me teach you something kind of cool on your calculators, all right? Have you ever used the zoom box? Not the boom box, the zoom box, okay? So here's what I want you to do. What I really want to do on my calculator is I would like to just kind of, let me see here, I would like to kind of just draw a box like around this much of my graph just to see what's happening in only that little window. Okay, so you can use the zoom box for this. So go into your zoom button, the middle button, and you see how number 1 is your box? what you're gonna do, go ahead and push number 1. And it's waiting for you to find a corner of the box. So what you'll want to do is you'll want to use your right, left, up, down arrows, and you'll want to get a corner of your box placed where you want it. So like maybe a little bit to the left, so you can still see these 2 points, or at least one of them. So get to a corner of your box. When you're there, push enter. And your blinking cursor changes just a little bit. Now what you're gonna do is use your right, left, up, down buttons to get the opposite corner of your box. Okay, so right, left, up, down. And once you have the opposite corner of your box, once you've got it placed where you want it, once you push enter, it's only gonna draw what's inside just that box. Which then kind of, it really zooms in on just a small area of the graph to kind of let you know what's going on. So, can you explain to me then, once it gets to my Y-intercept, explain to me what it does, because I know my asymptote is something I'm supposed to get closer to, but yet here it looks like it's gonna go up. Okay, so am I actually getting closer to this asymptote, according to your graph? Okay, so I didn't do this, let me make sure you're looking at a good thing. So it's kind of hard to tell for you guys. Okay, so go back to your standard window. How far did you take it out? How far did you take your box out? Go back to zoom standard, zoom 6. Let's try the box again. Only this time keep it really a short box, but take it all the way out to the end of the screen on the right. Take your box all the way out to the end of the screen on your right. So make it a short rectangle. And then take it all the way out to the right side of the screen. And then push enter. That shows a little bit better what you're looking at then. Okay, so your graph is going up, right? But then it goes back down, exactly. So basically, it goes up. Now, I don't really know when it stopped. I don't know what the maximum is because I didn't go look for it, but you could find it if you wanted to. But what happens is it comes back down and gets closer and closer and closer to my horizontal asymptote. Now let's deal with Devin's question, okay? Because it's about to drive Devin crazy that we're crossing over an asymptote. It is, isn't it?
Just a little.
Just a little, okay? Because Ms. Roberts keeps saying you can't touch that. But here's the thing, I've only said that for vertical asymptotes. I've only ever said you cannot touch a vertical asymptote, which is still true. You cannot touch a vertical asymptote, okay? Now, you can, as we have now seen, you can touch a horizontal asymptote. What we really care about with horizontal asymptotes, it's what's happening out on the ends. Do you see how way out on the ends, I'm still getting closer and closer and closer and closer and closer to that horizontal asymptote? That's really what I care about. To show you something that's cool, you'll never deal with this in Math 110. You don't even deal with it in Math 111 if you take that. It's called an oscillating graph. Where have you heard that word before? Where have you heard oscillating? Have you heard that word? Yeah, it's a fan. Have you ever heard of an oscillating fan? Right? Okay. They even have white noise that sounds like an oscillating fan. There's this oscillating graph in trigonometry, and it's a wave. And this is my horizontal asymptote, and it does something like this. And it keeps getting closer and closer and closer and closer and closer to the horizontal asymptote, but it crosses over it an infinite number of times, okay? So that's kind of the same issue here, only a lot less times. I am allowed to cross that horizontal asymptote. That's totally legal. What I'm really looking at is out on the ends, am I getting closer and closer to it? Okay, so I will continue saying you can't touch that, only in regards to the vertical asymptotes though, okay? All right, so for example 5, okay, go ahead and try this one in your groups. It's slightly harder than example 4 because of the way we start, but we have done one kind of like this, at least the beginning of it. So talk with each other about how you're going to go about this. By the way, if you're the one who did a lot of the talking on example 4, you don't say anything and let the other people do the talking. I'm not saying you can't say anything, just don't do all the talking. I want to hear lots of participation in your group.
His first birthday?
How's he doing?
No. In the mom?
Well, you do.
On the bottom of X minus 5 and X plus 2.
I don't say human words, but they definitely talk. They tell me what they want for sure. We all soak. Nothing say over here. You're just staring into space.
I'm staring at the paper.
Oh, okay, okay. Just, I know.
Plus 3 X minus 2.
So, you're gonna get half credit off for what you just wrote down.
What do you mean?
Now, this is the good place to make mistakes.
Yeah, so degree.
Oh, which one?
Which one was just Y equals 4.
Good.
Yeah. I was literally like 3 minutes away from getting late, like I'm contemplating just doing like auto and stuff, so I really woke up at 9 and I was like, oh my gosh.
Oh my goodness, well, way to go for getting here on time. That's aggressive,
I live 10 minutes away, but like,
but still,
eyes.
and you look decent too, so I would not look like that if I did. Of course, I live in Taylor's, so I would not have been able to get here. I got a question for you on this one. Check with your partners and see if they got the same thing as you did.
I'll see what
Okay?
I think so.
How are we going over here?
We're trying to figure out the X.
Okay.
Okay. I got n heavy 0 and choose 0. Why? But there's this.
Yeah.
Do fractions.
I got fractions.
Do 12 fifths.
That's what I got.
Are there any that you know for sure that are not confusing?
Okay. Can you split these up into separate, like out of separate examples?
They're all separate factors, is that what you're asking me? There are 3 factors on top.
So you said each of those.
Mm-hmm.
So that would just be.
So I want you guys to talk about that.
The Y-Intercept, should I understand it right? It's X equals 0 and something
So which one do you want to work with? And to be honest with you, I don't care if it's this one, or this one.
So it's the same as the first one?
No, the Y-Intercept. Okay, so then let's do what you said. What was it you said? Okay, so let's maybe just come over on some scrap paper or something, and let's make all the x's equal to 0.
So just put in the answer.
And you do have a 4 there, so you can't ignore that 4. And do the same thing with parentheses down the bottom. Okay, so now let's simplify that. Hang on a second. So here, it's multiplying, but you switched it into subtraction. Okay, and keep the negative. So now, there we go. Now, can you do me a favor? Can you do the exact same thing with the original question? Plug in zeros? Why? Yeah, so that becomes 0, that becomes 0, only leaving you a negative 24. That becomes 0, that becomes 0, only leaving you a negative 10. It's okay though, I let you go through all that because this is still correct. Okay, I don't care if it's longer, that's not a problem. But this one is easier. Okay. Did that make sense? Okay. Okay, so what did you guys do first? Yeah, even before vertical asymptotes, shouldn't we factor? Okay, so, and there was a GCF on top, wasn't there? A 4. So once you factored the 4 out, what did you get for the other 2 binomials? Okay, I'm trusting you. Is that what you guys got? X plus 3x minus 2 with a 4? Okay, on top. And then somebody else, what were the two binomials on bottom? X plus 2. Oh man, I thought we were gonna have a hole in the graph. Okay, so so what did you get for vertical asymptotes then? Okay, and then what did we get for the horizontal asymptote? So definitely vertical asymptote, it's easier to look at the factored version. Okay, what version to look at for the horizontal asymptotes? The original. And what do we have for the horizontal asymptote? Okay. All right, and then no holes in the graph. Don't worry, we're gonna do one with some holes in the graph. Okay, so you guys were a little bit, you were discussing your X-intercepts. What did you end up finding out?
Well, you said 4 equals 0, that's not true, so that's not an X-intercept, so it would just be -3, 0, and 2.
Very good. And I love that you kind of worked through that. Another thing to think about there, Mary Alice, remember back when we were dealing with degrees, if my degree is 2, how many zeros should I have up to? 2. I should never have 3 on something that's just a degree of 2. So that's another way to kind of check yourself on that. And then the Y-intercept, what did we get for the Y-intercept? What did you get? Oh, I hate decimals. Wasn't it like 12/5?
12/5.
That's okay. I would still accept it. I just hate it. So 2.4. It's about here. Okay. All right. So now we're ready to go to the graph. So what did you find? Again, let's look at how the domain is split up. So let's just look at the left side of the first asymptote. What's happening on the left side of the first asymptote? By the way, before you answer, I can already tell you it's got to be down here because there's a point here I got to go through, right? So I don't even actually need my calculator, although the calculator you want to check is one way to check yourself. So is it just a normal parent curve here? Okay. All right, how about between the asymptotes? And again, I can totally see, I know I got to get close to this asymptote, I know I got to get close to this asymptote, and I know I got to go through those 2 points, okay? So let's talk about this asymptote. Am I getting close to the top of this asymptote or the bottom on the right side? To the top, okay, so I'm going to be up here. Obviously, then I'm guessing I'm going to come down and hit these 2, right? And then am I getting close to the top or the bottom of this asymptote? Bottom. So this is not a bouncer, this is a breaker then, right? Okay. So, and notice that here's another time where I'm crossing over a horizontal asymptote. Is this what it looks like? Okay. And then the last thing is to the right side of the second asymptote. Again, I haven't graphed it, but I'm gonna guess that I need to be up here, and the reason I'm gonna say that is I don't have an X-intercept. If I were down here, I would need an X-intercept, and I don't have that. So am I correct? Am I up here? And is it just like a normal parent curve up there? Okay, for the last one that we're gonna work today, I'm gonna change the equation. Okay, so we're not gonna do what's printed. Do you have any questions on the last 2 that we've done? Are we good? The last one will work together, but we're not gonna do this one. This one's a little too easy. I wanted to have another one that was just a little bit more challenging, but we're gonna work it together. And besides, we still need to work, spoiler alert, we still need to work with holes in the graph. Okay, so this one's going to have holes in the graph. So we've got here x squared plus 5x plus 6 all over x squared plus x minus 2. Okay. So what's the first step? Yeah, we got a factor. Okay, so how does the top factor? Okay. And how does the bottom factor?
X plus 2x minus 1.
And automatically, what do you notice? I've got identical factors. Now, normally in math, what do we do when you've got identical factors on top and bottom? You cancel them out, you cross them out, and that's exactly what we're gonna do here as well. Let's deal with the hole in the graph first, since this is the new part of this lesson. Okay, so let's deal with the hole in the graph. I know I have a hole in the graph. Can you describe to me, if I were to draw a hole in the graph, what would that look like? Yeah, it's just a little open circle, right? Is it a line? No. So like if I were going to write down what my hole is, I'm not going to put the equation of a line. What am I going to write? I got to write a coordinate. Okay, so if I have to write a coordinate, the x piece is the piece that makes the 0 on top and on bottom. That's that identical factor. So look at your identical factors. What makes your identical factors 0 on top and 0 on bottom? A -2. That's the x piece of your hole. Okay? Once you get the x piece of your hole, go ahead and cancel those identical factors. And now you have a new equation that you're going to work with for the rest of the time. That new equation, x plus 3 over x minus 1. Okay. All right. Now, I know I've left the remaining part of the hole. Okay, that's okay. I'll come back to that. Look at the new equation. What's the vertical asymptote on the new equation? X equals 1. Don't go to the old equation because I'm not going to have that vertical asymptote at the same place where there's a hole. Okay? So I'm looking at the new equation. What's the horizontal asymptote? Not Sierra. Half credit. Good. Y equals 1. Hey, normally, when you have an x value and you want to find a y value, what do? Plug and chug. That's exactly what we're going to do. Now, don't go and plug it into the original. You'll get 0 over 0. Okay? Plug it into the new guy. So when you take your x value and plug it in, what do you get on top? Okay, you're plugging in this x value. You get 1, right? -2 plus 3 is 1. And what do you get on bottom? -3. So I've got a 1/3 negative. Let's go put those 3 things on our graph. And I'm going to spread my graph out. That 1/3 scares me a little bit. So let's spread our graph out. I'm not going to spread out the x-axis. I'm only going to spread out the y-axis. And you can do that. You're allowed to do that. Okay. So let's make our x-axis normal. So here's 2. Here's -2. And then spread out the y-axis. So let's make this 1. Okay. So my vertical asymptote is at x equals 1. Was that a sneeze? Bless you. And our horizontal asymptote is at y equals 1. So again, I did spread that out a bit. And then our hole in the graph is at -2, -1/3. So that just gives me a little bit of leeway there. So I put it 1/3 of the way down. Okay, and remember, it is an open circle because this is a hole in the graph. All right, let's go get our X-Intercept. Stop. X-Intercept comes from where? Yeah, whatever makes the top 0. Don't look at the old top, look at the new top. Okay, so where's our X-Intercept? Good, -3, 0. So I can put that on my graph. And then how is it that I find a Y-intercept again? Plug in 0 for X and solve. Abigail, I'm gonna let you do this one.
I just felt that.
You what?
I felt you were gonna.
You did? That's because you can tell the future. That's quite impressive. So what's our Y-intercept, Abigail? Mm-hmm. Yep. And by the way, Abigail, if I had even chosen the original, I still would have gotten the same thing because all 4 of these terms would have been 0, and I would have had 6 divided by 2 with a negative. Okay, so. All right, so now are we ready to graph? Okay, suggestion. Okay, word to the wise. It's way more safe to graph the original. Have you guys ever messed up on factoring before? I have. So it's safe to graph the original because if you graph the original and you made a mistake, this is the time where your calculator is going to catch your mistake. Okay, so graph the original. Make sure you put parentheses around the whole top and around the whole bottom. Okay. Now, I didn't graph this, so I have no idea what it looks like. Okay. So you're going to have to help me out. On the left side of this asymptote, what does it look like? Is it a normal parent curve? Does this look like kind of like a parent that's been shifted around? Okay. Does it look like the reciprocal or the reciprocal squared? The reciprocal. So yeah, so I've got my fence, I've got this. We just have to make sure that we skip over the hole in the graph. Don't forget to hit all 3 of those coordinates. I mean, don't go through the hole. That's a break in the graph. Interestingly, can you see the hole on your graph? Is it visible? It probably isn't. It's so tiny, you probably can't see it. You can see it in your list. There would be an error in your list, but you can't see it on the actual graph, okay? And then up here, I don't have any points to depend on, so I'm just gonna graph the curve and use my fences for that. Okay, so as a recap, before I let you go, that hole in the graph, figure out what the X value is, because that's what you're canceling. Okay, figure out what the X value is. After you canceled, to get the Y value, plug and chug into that new equation to get the Y value. Okay? All right, guys, so that's all I have for you today. We'll do 5-3 next time. And yeah, see you Thursday. Have a good day, guys.